Hi everyone, welcome to BIM Like a Boss episode 7. What is BIM and what does it mean for a design engineer? Thanks so much for taking the time to join us today. Today we'll cover what BIM is, how a design engineer can use BIM, leveraging BIM data with Unify, and beyond. At the end of our presentation, we'll get to our live Q&A with questions from our audience. If you have any questions that come up throughout the presentation, please use the Q&A tool at the bottom of your Zoom window to ask. We will get to as many questions as we can at the end of the presentation. Without further ado, I'll turn the floor over to our host, Unify's very own BIM specialist, Jay Merlon, to get the presentation started. Jay, take it away.
Thanks, Laura. All right, so before we get started, here's just a little bit about myself. I'm a Revit MEP certified professional and have been using Revit since 2005. And you can even see some of my work in the background of this slide here. I've got over 12 years of experience as BIM manager at multiple MEP firms, including a national BIM lead role at AEI. And in 2016, I also founded the Dynamo user group here in Seattle, which now has about 200 members. So let's go ahead and jump into our first topic here. What is BIM? And maybe first we can talk about what BIM stands for, because BIM is actually an acronym for Building Information Modeling. And if you look up the definition of BIM, you'll find even several variations on what it really means. Is it a technology? Is it a process? Or is it a new type of CAD software? Well, technically, it can really be considered all of the above. So I think probably the easiest way to understand what BIM is to really have a look at the history of how we've been designing and constructing buildings for generations. Working our way from left to right, we see that we started designing buildings in an analog format. So we were generating drawings by hand, and yes, that means pencils, erasers, paper, vellum. There really was no digital information here. And in fact, even if you were to scan in a drawing and convert it to a PDF, considering that a form of data is even debatable at that point. Moving forward, we adopted more digital workflows, and at the core of this era was really computer-aided drafting, also known as CAD. So in this stage, we started drawing lines and shapes to represent buildings. Eventually, we even incorporate three-dimensional models into this process as well. But the point to be made here really is that although we are drawing lines and shapes to represent these building elements like walls, duct, or pipe, these elements typically did not have any data associated with them. So in other words, a drafter would draw two parallel lines. The software didn't really understand what those lines were supposed to represent. And because there was very minimal data tied to them, such as maybe a layering name or a color, there was no indication of what that object really was meant to represent. So, and as a side note, I will say that this eventually became our introduction to data, because there were some progressive CAD standards that I've seen that actually accomplished quite a bit in terms of intelligent modeling. And finally, I like to refer to today as more of an information era. So a common misconception when comparing CAD to BIM is referring to CAD as 2D and BIM as 3D. But as I mentioned, CAD also supported three-dimensional modeling as well. But really what sets us apart from our predecessors is the process and technology that revolve around the data within these 3D models. So now, not only is our software intelligent enough to differentiate a duct or a pipe from a wall, but the elements modeled in a building information model can be considered a container for data, and data that is extremely valuable to engineers such as yourselves, because you can use these for things such as calculations. So let's start to talk about the concept of BIM data, because what do I mean by that? I mean, the data within BIM should strive to be usable information. So when I say usable information, what I mean is the data should be accurate and useful. Now, depending on who you are and what you do is what defines what is considered useful data. So with that being said, let's look at a simplified project lifecycle to better understand how BIM data can really be used throughout each phase. So first, let's start with the design phase, which refers to architects and engineers on a project. So these are the folks who not only create data during their modeling process, but they'll also consume data from either their model or other models and other disciplines as well. So think about my last slide and about how we were drawing on paper for decades and even moving into CAD. If we needed to communicate information about a project, we'd probably add that information to a drawing. But today, what we're working towards is using the data in your model to communicate that project information. So whether it's as simple as a manufacturer and a model number, or even as complex as the engineering data for a commercial air handling unit that helps you size your duct. And then the next phase of the project life cycle is construction. So during construction phases, the most obvious benefit of BIM really comes from the 3D geometry, which is used for spatial coordination and even prefabrication. But in terms of BIM data, contractors can actually use that data for helping with things like estimates or even construction scheduling. So back to the concept of considering intelligent objects as BIM containers for data, contractors can actually add parameters such as cost or even man hours to these elements that would help them realize some of these benefits. And just to add to the concept of using data to communicate project requirements, oftentimes contractors will even refer to the data within a design model to get a better understanding of design intent. Now, on that note, one word of caution is in our space, it is actually a known fact that data within a design model can contain inaccuracies, at least in the US, where we don't have strict government mandated standards. So you will see construction teams still working off of drawings, as those are the contract documents, not the model. So I do want to put that out there as a word of caution. I do hope that we get to the point where model data is as valuable as drawings someday. And then what about post-occupancy? So the owner/operation side. Well, I believe they're still getting their feet wet in regards to BIM data, but there really is a lot of potential here. So today, the usable data from BIM for an owner comes from the ability to track assets in a database rather than hard copy binders or even sticky notes. Now, I will say there is a new breed of BIM savvy owners out there who are evolving their project delivery methods to revolve around BIM. So part of that evolution involves strict standards for these design and construction teams that they hire, and implementing those standards mean that they are provided usable data at handover. And if you've been wondering why we're all implementing this new technology and process, and whether or not there are some solid benefits, here's just some basic data from Dodge Data and Analytics. And specifically have a look at the dark blue bars, which represent the folks who use BIM on more than 50% of their projects. So let's just focus on the top two for the sake of this presentation. 89% agree that BIM tools improve collaboration. So we're definitely seeing more and more model sharing these days and more integrated project delivery approaches, which oftentimes rely heavily on BIM technologies. So you can also attribute this improved collaboration to using data within these models to communicate project information. And then 84% think that BIM eliminates rework. So this is most likely due to less need for manual drafting and even calculations, because once a change is made to an element in a model, it's actually reflected everywhere in the project, meaning schedules and calculations are updated automatically as well. So now that we've gone through a high-level overview of what BIM is, let's have a look at some examples of how BIM can actually help a design engineer do their job more efficiently and accurately. So one clear advantage is the simple fact that it's a more intelligent way of modeling a building. And when I say intelligent, what I mean is we aren't just drawing lines and shapes and adding text to these drawings anymore. Every element that is added to a building information model can now have that data tied to it. So again, this can be something as simple as manufacturer name or model number, but it can also help you out with engineering calculations. Now, before I start with a couple of these examples, I just want to make an important note here that all of these examples are based off of Revit, so they're Revit specific, but I do want to make it clear that there are dozens of BIM applications out there to choose from. Some even have specific purposes such as energy modeling or lighting calculations. So just keep that in mind. Although I'm sharing examples here that are Revit specific, there are options out there, and I encourage you to explore all of those tools before investing too much time into any single one. So our first example here is really for our electrical engineers on the line. So earlier in the presentation, when I mentioned before BIM, we used pencil and paper and eventually moved to CAD. Well, even in the early CAD days, you'd most likely need to count system components manually. And I personally remember having to highlight symbols on printed floor plans to count fire alarm devices on a circuit for calculating voltage drop for that circuit. And not only was that excruciatingly tedious, but there was also a lot of risk associated with that process, because obviously the possibility of human error is always a factor. And with that risk, you also needed to manage, let's say, an Excel spreadsheet to handle all of the formulas that actually executed your calculations. That, having that separate data set in a spreadsheet is also another opportunity for error. So in BIM, you can actually mitigate some of that risk because you have the ability to use objects as containers for that data to help you with these calculations. So this means that applications such as Revit comes with this set of tools to help you manage devices on circuits, for example. So when you're actually building a virtual circuit in Revit, you can have your panel calculations update automatically. And aside from it being an obvious time saver here, by automatically calculating any changes to that circuit, you're also reducing the risk of missing devices or maybe a typo in your calculations. So in this screenshot on the far left, you can actually see the electrical data tied to an outlet or receptacle. Using that data, Revit is able to do some simple math and generate the panel schedule that you see on the right. So that means as I add additional devices to this circuit in my model, the panel schedule will also update as well. So think about all the time saved here, and again, reducing the amount of errors associated by letting the software do the work for you. And here's an example of using BIM to help out with HVAC design, automatic duct sizing. So when it comes to laying out ductwork in your HVAC design, duct sizing is one of those relatively simple yet tedious tasks as well. And again, you are opening yourself up to the possibility of human error. But in Revit, there's a feature which automatically sizes ducts based on friction, velocity, or both. And you even have the ability to set constraints such as the height or the width of the duct. So just in case you're working within tight constraints of the ceiling space, which almost always happens, Revit allows you to constrain the height of your duct to allow it to fit into that ceiling space. And now think about when the architect revises the rooms and changes the HVAC requirements. Now, would you rather manually calculate these new numbers using your handy-dandy ductulator, or programmatically import the data from an architectural model and let Revit resize the entire system for you? By the way, a quick note for all the plumbing or piping designers out there, Revit also has features to automatically size pipe based on fixture units of plumbing fixtures. Another example for the HVAC designers out there, right out of the box, Revit also provides heating and cooling load reporting. So when I mentioned that objects can be containers for data, spaces in Revit are another example of an object that can contain data. So one of the benefits here of using BIM for this exercise is the fact that you can copy room data, including the 3D geometry, from a linked architectural model. And this helps you define those HVAC spaces and zones within your mechanical model. And this data can be used in your model directly without having to manually input that into a spreadsheet or other database, although spreadsheets and databases do have their place. But the point here is that using data as a form of sharing project information is the key here. In this example, an engineer was able to use the data provided by an architect, actually provided by the architectural model. And even if the engineer is only using, say, the name and number and the occupancy of the rooms, it still beats having to read through hundreds of lines in a room schedule, only to be required to build your own schedule as a byproduct. As a side note here, this is a great example of data being shared across multiple disciplines for BIM coordination from an engineering perspective. And I say that because typically when you hear the terms BIM and coordination in the same sentence, it's referring to spatial coordination to aid in construction. But I would say from an engineering perspective, we can actually consider this type of communication using data being a form of BIM coordination, because rather than using the 3D geometry to coordinate, we're actually coordinating using the data provided by either other team members or other firms. And we've covered a couple of examples for the MEP side of design engineering. So let's look at a structural example here, which admittedly is the discipline that I have the least experience in. But I did, however, come across a post by Thomas Fudala, where he demonstrates how he was able to use BIM data to generate wind loads for a structural analysis. By the way, the link is here at the bottom of this slide. If you're interested in reading up on the details of this workflow, it is really a great read, so I highly recommend that. But so continuing on the story, in order to apply these wind loads to his structure in Revit, he actually found that he needed to add them manually to several elements within his model. So that's a lot of mouse clicking, and I think we can all agree that in this day and age, we are more than just button pushers. So what impressed me really most about Thomas's workflow is the fact that he was able to identify a limitation in the application and then create his own homegrown solution. He ended up using Dynamo to handle his calculations due to those limitations that he found in Revit, which, by the way, if you aren't familiar with Dynamo, definitely look into it. I highly recommend that you start at least playing around with it. Getting into the details of what Dynamo does is really off topic for this webinar, but it's definitely worth mentioning because I do feel that it's a tool that can be used heavily by design engineers, especially those who need to import, export, or even manipulate data within Revit or external of Revit. Like I said earlier, spreadsheets have their place, and if your firm is heavily invested in trusting the calculations they run on their spreadsheets, maybe this is an opportunity to pull data out of your model, manipulate it in Excel, and then bring it back into your model so that all of the data is stored within Revit. So for those of you design engineers out there who have run into some of these limitations of Revit, you may want to start exploring Dynamo to learn how you can interact with that data. And again, check out the full article and the link at the bottom of this slide to learn more about what he was able to accomplish using Revit and Dynamo. So we've talked about a few ways engineers can use data for calculations, but what are other ways that we can consume that data? We're all technically creating data, whether it's intentional or not. So what really can we do with it? And before I jump into answering that question or attempting to answer that question, let's first look at where the data in BIM comes from. I keep going back to the concept of objects within your model being containers for data. So have a look at this illustration, and you can consider the building in this illustration your project. It represents the building information model. And now think about the objects that are loaded into this project. So whether it's a desk, a door, maybe servers, it could even be receptacles, mechanical equipment, all of those objects are what we call BIM content. But as you can imagine, BIM content, especially at a large scale, is difficult to manage. So there are issues with organizing the content to make it easier to find, or maybe there are permissions controls that need to be implemented for your firm across multiple libraries. And maybe you just need to have increased visibility of the data that is defined within each piece of content. Because in terms of Revit, a Revit family is the element that lives in your model. Now that's stored as a file. It could be on your network drive or on your local computer, but the Windows really has no visibility into that information that is stored, and that data that's stored within these Revit families. So how do we solve that? How does Unify actually help with that? Well, we provide a solution that really makes it easier to find and use your firm's library of BIM content, and we call this Unify Core. Now, without the support of a content management system such as this, it actually can be really difficult for users to find content, particularly with large libraries, as they tend to get extremely large. And they tend to need to have to search through hundreds of Revit families or other content types, especially if they're stored in a file folder structure somewhere on a network drive. So here I've identified some of the key features that will actually help with engineering disciplines. So again, find and use BIM content easily, permissions-based libraries, and then features for multidisciplinary engineering firms. So some of those features are things like the ability to share content across disciplines. So you've got stuff like a pipe fitting that technically can fall into the mechanical discipline and the plumbing discipline. Now, if you're invested in a file folder structure to store that content, what do you do there? Do you duplicate it across multiple folders to be able to provide that to those disciplines? Here in Unify Core, we actually prevent you from having to duplicate any of that content. And finding content is really only half the battle, because what we want to do is give you visibility of the data that is stored within these objects as well. So here on this screen, you can see that you're able to actually review a family's parameters before loading it into your project. So here you can see in this example, there are some engineering data points here that can be useful for your calculations that I mentioned earlier. The point here is the ability to see the data within this family without having to open it in Revit, because conventionally you would need to open this in Revit, review the parameter data to make sure that it's the family that you're looking for, only to finally load it into your project. But here you can have that visibility of all the family types and parameter data associated before even opening the family. And in addition to giving our users the ability to review that parametric data of each piece of content within their library, we can also provide workflows that help your team load the appropriate data standards into their project. Now, this is helpful because in multi-discipline engineering firms, in order for this data or information to talk to each other in the form of data, they'll need to use a common set of shared parameters. Now, again, this is specific to Revit, but if you're not using the same shared parameters, the data set is not technically the same data set. So here you can see on this screen, here's one way that we're providing value to those multidisciplinary engineering firms by giving you the ability to store these schedules in your library alongside the rest of your content. Because what happens here is once you insert this schedule into your project, along with that schedule comes all of those shared parameters. And in other words, you're creating a data standard here that you're now able to import into your project. And aside from content, BIM data can actually take on another form. So there's been a growing need to have visibility of the data that their projects are generating. So sort of zooming out and now looking at the data of a project. So an entire building, maybe it's multiple models all aggregated together to create a data set. So with Unify's project analytics application, you can actually do that zooming out and have a holistic view of all of the model data across multiple disciplines or offices. And I really like to look at this as comparable to big data, but in regards to your BIM data. So again, being able to see holistically all of the data that all of your projects are generating and consuming is the goal of this product here. So with this tool, your entire team, whether they use Revit or not, can now have visibility of the data and contents within these models. All right, and just a quick recap here before we jump into the Q&A session. So BIM data, let's start to look at that as a new way to collaborate with multiple disciplines. So again, using the data to communicate project requirements and information is key here. I will say that we're not necessarily there yet as an industry, but I think we're making great strides towards that. And there are several tools out there, including Unify's products, that can actually support some of that collaboration from a data standpoint. Good data in BIM can help mitigate risk, and this is absolutely true. And I want to highlight the term good data here, because bad data can actually create risk, obviously. But good data in BIM can help mitigate that risk. So again, think back to that electrical example of adding devices to a circuit. Something as simple as that allowing the software to do the calculations for you as you're making changes to your design model. And then lastly, of course, Unify can help with our suite of tools that I've provided a short overview of.
Awesome.
All right, with that, I'm going to go ahead and hand it back over to Laura. Thanks, Laura.
Thank you so much, Jay, for that informative presentation. As I mentioned at the beginning of the webinar, please use the Q&A tool on your Zoom window to submit your questions for Jay. It looks like we've already had some great ones come through, so let's go ahead and get started on those. Jay, you mentioned something about BIM coordination with an emphasis on data. Can you elaborate on that?
Yes. So the BIM coordination with an emphasis on data. So earlier I mentioned a lot of times when you hear the term BIM coordination, people are referring to spatial coordination. So looking for clashes, for constructability issues and things of that nature. But part of what I'd like to propose here today to all of our engineers specifically on the line is how can you actually start to use the data within your models to coordinate other users' data. So other team members, maybe it's another discipline. Again, going back to that example, let's take like a piece of mechanical equipment that maybe we'll tap into, we'll need an electrical connection. How can those two trades really, use BIM to its fullest potential? And really that's to get on the same data set and coordinate in terms of data using the parameters within your model.
Wonderful, thank you. The next question we have, does Unify run under DFS file systems?
That's an interesting question. I'll be honest, I don't know what DFS stands for.
So
that might be a
DFS. Sorry, DFS. So
yeah.
Okay, sorry. Just want to make sure we got the acronym in order. If the person who asked that question wants to spell the acronym. Okay, distributed file system. So does Unify run on distributed file systems?
Okay, yep. I do apologize here too. This is a little out of my expertise. What is a distributed file system? I'm sorry.
Hey,
is it cloud-based?
Okay, yeah. Let's maybe get back to that one. We'll follow up with you offline, the person who asked that question. The next question we have, do you have any recommendations on transitioning my MEP firm away from doing schedules in Calcs and Excel and investing more into BIM?
Sure, yeah. So, this is something that I've worked with firms on, quite a bit. And I think the main point to make here is picking a pilot project that is manageable. So that pilot project, maybe it's a smaller project. I wouldn't recommend. I wouldn't recommend trying to implement any new workflows or processes to, say a 500,000 square foot hospital, for example. That can, create issues. Although you will get some padding there with the bigger budget. But I will say, the pilot project is key. So picking that right project, and then also picking the right team that's associated with that project as well. So it comes down to also the people. So how open are they to experimenting with new technology? How married are they to the old conventional ways of doing calculations in a spreadsheet? So those are really 2 points there to make, the pilot project, the team, and then also really going back to content, developing all of that content, as early as possible, even if it's placeholder elements. A lot of times at design engineering firms, the schedules come extremely early. So that's one of the roadblocks there with, implementing BIM for schedules so early on in the project is really the objects need to exist in the model before you can build a schedule. So, trying to strategize there on, using placeholder equipment to start off the data on the right step is also something I would consider.
Excellent, thank you. Our next question, I'm at an MEP firm where each discipline owns their own model. What are some tips on sharing data between these separate models?
Right, so we've implemented, in the past I've implemented a few workflows that are interesting because when you start collaborating in multidisciplinary models, especially if you have individual models per discipline, Again, I'm going to speak in terms of Revit because that's where my experience lies. But you could do things like copy monitor equipment between models. So with that, as you're copy monitoring that equipment, with that comes the data that let's say you're an electrical engineer and you need to supply power to an air handling unit that it lives in the mechanical model. So you might be able to copy that into your model and use that data. Copy monitoring really is an advantage because it will allow you to monitor that element for changes. So there's an advantage there because, you know, during design phases, things change all the time. Things are shifting around and moving. So you need to be able to monitor that element for changes. So that's where the copy monitor comes in play. And then second, there are some other sort of more out-of-the-box techniques that I've implemented as well, such as maybe having your own element live in your model and then and then storing all of the relevant data in that element that you own. So that's usually helpful if maybe there's a third-party consultant that is, you know, generating that data for you to use and consume and make your own calculations on. But there is one caveat there is, you know, without it being monitored, you won't be able to tell if it's changed or not without some additional scripts. So just going back to, you know, the original question is what are some tips on sharing data across multiple models? I think, again, you know, copy monitoring is important because you can keep an eye on changes. Creating your own object, even though it's maybe not visible on plan view, but, you know, creating your own object to store your own data in is also another critical point to make. And then obviously making sure that the data is accurate in your model, because there are times as firms are looking to adopt BIM or even just Revit, there can be bad data that appears and surfaces as users are trying to tap into that data. So that's another thing to watch out for as well.
Thank you very much for that thorough answer. We have another question in. Can Unify be used to manage blocks in a 2D process in smart objects and software such as Civil 3D?
Yes, we can. So we do have AutoCAD add-ins, which, as far as I understand, are also compatible with Civil 3D. So those AutoCAD add-ins for Unify, really you can import a block from your library into your drawing. You can export blocks out to your library from AutoCAD, and then you can even store your drawing templates in your Unify library as well. So if you click on a drawing template from your library, it basically creates a new drawing for you in AutoCAD as well. And then also, as a side note, we are looking to release our Bentley MicroStation add-in as well, which gives you that similar process, the storage of your standardized content, as well as the ability to insert that into your model.
Okay, awesome. Thank you, Jay, for answering those questions. And thank you so much to our audience for engaging with us and asking those great questions. We will be sending out a recording of this webinar to all of you who joined us later on. And once again, I wanted to thank you all so much for taking the time to join us today. We look forward to having you at our next webinar and hope that you have a wonderful day. Thank you.
All right, thank you, everyone.